difference, union, and intersection. Now today we'll continue with the algebra of sets, De-Morgan law, and the duality principle, and then we will start with the probability definition and its axioms اللي هي rules حقتها إن شاء الله. So we went through the De-Morgan Venn diagram, equality differences, union, and intersection. Now we'll define the complement. The complement of a set is basically denoted as A bar, as you can see here. So a set A, its complement is A bar, which is everything except A. So all the elements in the universal set S, except, not including, the elements in the set A. Okay, so if this is A, then the blue part is basically the complement of A, is everything except A. So now we can see that the complement of the phi, or the null set, is the universal set, and conversely the complement of the universal set is the null set. Now if we union a set with its complement, for example A here, and the complement of A, we get the universal set. If we intersect a set A with its complement, we get nothing, phi, because there is no common factor or common element between a set and its complement by definition. And if we take the complement of a set twice, so a complement of a complement, we get the set itself again. So the complement of A is A itself. Now using the complement, we can redefine the difference. تذكروا A minus B was all the elements in A excluding the elements of B. Okay, all the elements of A that are not included in B, that are not in B, which is basically X, such that X is in A and X is not in B. And here is an intersection operation. Okay, when we say and, logical statement and, this is an intersection operation, which means that this rule and this rule have to be satisfied. Where if we say or, it means that we are talking about what? Shabab? Union, exactly. Okay. So now if given this approach, A minus B is all elements in A and not in B. So what are the elements that are not in B? By definition, they are B complement. So A minus B is A intersect B complement. And if you look at it in the Venn diagram here, A minus B is A, which is the blue curve here, the circle A, and B complement. What is B complement? If everything here okay, including the A. So A intersect this dashed space is basically the blue space, which is A intersect B complement. Okay? Questions, Ishmael?
Can you please repeat again how A minus B become A and the B complement? How did we get the same result?
A minus B, by definition, what is A minus B? When we talked about A minus B, A minus B was all the elements, هذا هو definition, in A that are not in B. All the elements included in A that are not in B. طيب معناها إيش? It's X such that all elements X such that X in A and X is not in B. طب what are the elements that are not in B?
The blue. You're right.
No, it's S minus, it's basically S minus B, صح?
Yes.
Which is B complement. So
okay.
A minus B is A intersect B complement. Okay? Others, Shubha? Okay, so now some set operation properties. The first one is commutative. Well, basically, if we have A union B is the same as B union A. It doesn't matter where we start. Similarly, the intersection. Whether we start with the set A or the set B, the result is the same because we are counting the elements inside them. It's also distributive. So A union B, sorry, intersect B union C is the same as A intersect B. This is not complement. A intersect B union A intersect C. Again, I will erase it because this is not complement. Okay? Similarly, A union B intersect C, we can distribute the union here, the red, over B alone and C alone, so C alone, individually. So very similar to the summation. Associative, well, basically, if we have A intersect B intersect C, we can group any of them. We can group here B and A alone, and then intersect C, or we can group B and C alone first, and then intersect A. Similarly for the union. So it doesn't matter where you start, whether you start with A union B, like here, and then union C, or B union C and then union A. It's the same. Very similar to the summation in numbers. Any questions, Shimam? Let's talk about De Morgan's law. De Morgan's law tells you the following, and this is very important law when you want to simplify set expressions. For example, De Morgan's law tells you, okay, now if I have this expression, A union B, everything complement. Of course, you can always find what this is by simplifying it through counting the numbers or the elements inside everyone. However, De Morgan's law tells you very small, simple shortcut. A union B, all complement, is the same as equal to if we replace the union with the intersection and we replace the sets with their complements. So here, for example, A union B, everything complement equals A. The union change into intersection, as you can see, and B change into B complement. So simply, De Morgan's law tells you, okay, if I have a statement, an expression, the equivalence of that, in order to simplify it, will be to replace all union by intersection and all sets by their complements, if I want the complement of that expression. Another example is here. A intersect B, all complement. So we want the complement of this expression, A intersect B. Then I replace the intersection with the union, and I replace the sets A and B with their complements. So the answer will be A complement union B complement. So simply to complement an expression, a set expression, we replace all sets by their complements, all union by intersections, and all intersections by union. This is the rule. And this is very helpful when you want to simplify set expressions. واضح شباب? We'll come into an example after in a minute or two. Any questions? Okay, the last thing about set operation is the duality principle. Duality principle states the following. If you have an expression, okay, and you want to have its dual expression معناها equivalent expression. For example, if I have this expression, B union A equals A union B. This is an expression or a statement. The statement says the following. A set B union with A is the same as A union with B. Now, what is the dual expression for that? Dual means equivalent expression. If we replace all unions by intersections, okay, all unions by intersections, all intersections by unions, and the set S by phi, and the set phi by S, then we get what we call dual identity. So this is the rule here. Replace union with intersection and the S with phi and vice versa. For example, for this example, the dual expression or the dual identity for this will be to replace the union by the intersection. So basically by duality, you get this expression. B intersect A equals A intersect B. This is a dual identity. Dual means similar. Okay. Now exercise. تفضل.
How is this different from complement?
لا الكومبلمنت انت تبغى عكس الاكسبريشن. The opposite. الكومبلمنت you are not this is not dual to this. So the right hand side and the left hand side are not dual. They are equal. Okay? They are equal. Complement when you complement an expression, you replace the intersection with the union with the intersection, and the intersection with union, and you replace all sets by their complements. Okay? This is equality. This يعني right hand side here equals left hand side. In the duality principle, we are not talking about expression and you would like to simplify it, find its simplification. We are talking about identities. زي كذا عندنا مثلا شيء يساوي شيء. Expression يساوي expression. Now, what is the dual expression for that? A similar expression is this, for example. تمام? In the duality, we don't replace sets by their unions. The sets continue the same, only intersection by unions and opposite. And the set S with the phi and the opposite. Other questions? طيب, I want you to look at this exercise, شباب. Consider this, the two basic events, A and B, or sets A and B. Simplify the following. E, a new set, equals the complement of A complement union B complement, union the complement of A complement union B. Simplify it, شباب, and send me the answer over private chat. You have 1 minute. Simplify this and give me the answer over on the private chat in 1 minute, please. Mainly applied D. Morgan's rule.
دكتور كيف نكتب intersection علامة intersection؟
نعم؟
كيف نكتب علامة intersection؟
ما تحتاج.
So I sent you a picture of the solution.
مو مشكلة. picture تسلك يعني خط اليد إذا تبغى picture أو إذا تبغى solution easily. You will not need all these unions, intersections. It's very simple. طيب, we have 30 seconds. طيب, شباب. Are we done? طيب, so the answer is, let's see. Applying De Morgan's law, the union of A complement union B complement is basically we replace the complement with its complements. So A complement gives you A. We replace the complement, sorry, the set with its complement. So complement of B gives you B. And we replace the union by intersection. So this is the first part. Union, the second part, which is replace A complement by A, intersect B replaced by B complement. Okay? Now what is this? Those of you who would like to simplify. This is A intersect B. So this is the common elements between A and B. So if this is the sample space, this is A, and this is B. This is the first part. A complement B. A, sorry, intersect B. Union A intersect B complement. So what is B complement? Everything in S except B. So A intersect B complement is the rest of A. Right? So the first part, union the second part, gives you what يا شباب? A. Exactly. تمام؟ فشوفوا how helpful was the DeMorgan's law. This is looks very complicated, except that it's at the end it's very simple answer. So DeMorgan's law gives you very helpful tool to simplify set expressions.
دكتور
تفضل.
الوقت كده على طول ترى ما يساعد.
ايش هو الوقت؟
بتقول بس دقيقة واحدة على طول.
يا طيب. I did not give you something complicated. This is very simple.
بس على طول كده دقيقة ما يمدي.
طيب يا شباب. طيب يا شباب. This is we are in the class. I cannot give you 5 minutes for every exercise. واخر شيء أنا this is not a quiz. هي هذا جزء من participation.
نبي حقنا.
نعم.
مشاركة دكتور بنحسب الدرجات بعدين.
Exactly. أنا ما حد أنا قلت لكم من أول المشاركة مو معناها إنه الأنسر has to be correct. معناها إنك أنت معي وجالس تشارك. لا تخاف ما راح أظلمك. So please don't argue about the time and so on. لأنه عندنا وقت لازم نخلص الله يخليك. لكن don't worry about your answers. أنا قايل لكم من أول if you answer wrong معناها أنت معي and you are answering. This is not a quiz يا شباب. Please don't be afraid if you answer wrong. هي الفكرة إنك تكون معنا and you are trying to solve as we go. إن شاء الله يكون الوقت المرات الجاية أحسن بإذن الله. طيب. Don't be afraid of the answers. If you have a wrong answer, still send it. You will not be detected marks. لا تخافوا. هي الشغلة ما هي كويزات هذه. الفكرة إنك أنت معنا and you are trying to understand as we go. هذه بس participation. This is not a quiz. Okay? Is that fine with you? ما في رد؟
يا دكتور بس المايك خربان مو مرة زين.
المايك حقي ولا حقك؟
حقي أنا ما عليك.
طيب لا زي ما قلت لك don't worry. بإذن الله الأمور يعني أنا ما الترم الماضي ما حسبت أحد إنه جاوب شيء خطأ خلال البارتيسيبيشن. هي الفكرة إنك أنت معنا and you are trying your best to go over the material معنا وتحاول تفهم and so on وتشارك. لأنه في للأسف بالذات في الأونلاين في يعني يعني في بعض الممارسات إنه خلاص افتح هذا وسوي أي شيء ثاني which is wrong. فهي الفكرة إنه إحنا مع بعض هنا عشان for you to benefit مو عشان بس to satisfy الجامعة إنك أنت حاضر. تمام؟ طيب so this is basically we are set for the section about set operations. We are done with that. If you have any questions شباب before we move to the next part. طيب الآن the next part will be the probability definition and its axioms. Axioms هي قصدهم الرولز. الناس يعني اللي فيكم أول مرة يشوف الكلمة هذه. الرولز principles خلينا نقول. Principles of the probability. So now let's talk about the objective of this section. We'll talk about experiments, define experiments and the sample spaces. Once فهمنا sample spaces والexperiments, we'll talk about different types of sample spaces, discrete and continuous. We'll define events over sample spaces. We'll define probability and the axioms اللي قلنا عنها rules والprinciples. And then we'll talk about the mathematical model of the experiments and the probability definition as the relative frequency of occurrence. تكلمنا عنها قبل كده. طيب الآن for an experiment we need to define ثلاث أشياء عشان to be able to define probability or talk about probability theory we need to define three things. First of all, what is the experiment? Experiment is a single performance or a single trial of an experiment. مثلا tossing a coin. هذه an experiment. Rolling a die. Rolling two dice, tossing two coins, whatever. These are all experiments. Picking مثلا a number from 1 up to 10. مثلا أنا أقول لك اختار واحد من رقم integer from 1 to 10. This is an experiment. And so on. Anything that you think. Okay, measuring temperature today. Now, مثلا. This is an experiment. And so on. Measuring the voltage across resistor R. And so on. تمام? So experiment is something that you do that has outcome. Okay? It has outcome or outcomes. Something that you perform or you do that such that it has an outcome or outcomes. زي ما قلنا rolling a die unbiased die نسميها unbiased معناها ايش؟ It's equally likely that gives you one of the 6 phases. Unbiased means يعني عادلة. There's no fair die or unbiased die, unbiased coin or fair coin means it gives you the outcomes equally likely. Now we define the outcomes, the set of outcomes, as what we call the sample space. So here the sample space S, capital S. في الكتاب كله throughout all the class, this course will define sample space as capital S. The sample space here is the set of all possible outcomes. تمام? The set of all or including all possible outcomes. الآن if you have a die and you roll it, what is the set of all possible outcomes?
1.
From 1 to 6.
1 to 6. So this is basically S. It's the set 1, 2, 3, 4, 5, 6. The integers 1 to 6. The probability for everyone giving زي ما قلنا relative frequency. If you repeat rolling the die 1,000 times or a large number of times and count the number of times you get 1, count the number of times you get 2, and so on. Now, given what we call the relative frequency, you will find that the probability is roughly 1/6 of the time you get 1. You will find that 1/6 of the time, roughly speaking, or close to that, you get 2, and so on.
So it's
Okay.
1 over the sample space, the rule, right?
1 over the number of outcomes in the sample space. هذه ايش؟ Because it's unbiased. It's equally likely. مو دائما كذا.
Right.
Okay. يعني مثلا if I tell you pick a number from 1 to 10, there is no reason to think that you are more biased that you will pick one more than 10. خلينا ناخذ يعني أي شخص في الدنيا if you tell him pick a number from 1 to 10 and you get 1,000 of these people, roughly speaking, you will find that equally likely these numbers have been picked. بينما temperature, measuring the temperature today اليوم برد شوي, it's not equally likely that you get the temperature today 50 مثل 20.
Right.
اليوم لو تحسبها وبكره وبعده الايام البرد هتلاقي معظم الاوقات The temperature is around maybe 10 from 10 to 25. So it is
Doctor,
here.
like
تفضل.
doctor, like rolling two dice, two die instead of one. The rolling a 7 is most likely.
ايه حنيجي قصدك انت rolling two dice and looking at the sum of the numbers.
Yes, the numbers are not equally likely.
لا لا النمبرز نفسها equally likely لكن the sum of the numbers that you see and an example after that it is not the same. Yes. يعني your friend is mentioning if you roll a die twice, is not twice, rolling two dice and you look at the sum on the two faces هتلاقي انه بعض الارقام مثلا 7 و8 وكذا اكثر من واحد اكثر من 2 و 12 and so on. We'll come to that. Good note. طيب, so basically now we define the sample space. We define the probability set. For this example, for this particular example, we can define any event. ايش الevent? Event is a subset of the sample space. مثلا even numbers. An event A ممكن even numbers. Even number. يعني الداي تعطيك even number. In this case, what is the set A here? شباب
2 4
2 4
6.
6
ممتاز. So an event is a subset of the sample space. You can define any event. B number less than 3. معناها ايش هذه؟
2 1
1 and 2. Exactly. So basically, in order to talk about probability, we need to be able to understand the concept of sample space, which is the set of all possible outcomes from the experiment. The event, which is basically any subset of the sample space, and the probability, which is basically you can look at probability as, or define probability in terms of the relative frequency of these events. طيب الآن sample spaces you can have. تفضل.
I have a question, please.
ايه تفضل.
The event is basically just like an example here. We took 1 and 2 out of these 6 numbers, so it's just a condition, right?
هي يعني نسميها condition. ما هي condition لأنه حتيجي على أشياء حنيجي على أماكن ثانية. We will use the word condition. It's the event حدث. You roll a sample, you roll a die, and you are defining حدث معين, event. ايش هو الحدث؟ انه الرقم اللي يطلع اقل من 3.
Okay, right.
Okay, this is an event. لأن condition هذه حنيجي عليها نستخدمها في أماكن كثيرة ثانية, so you don't want to use condition here in this context.
Okay.
تمام. ممتاز. الآن we can have in general for any experiment, for an experiment, the sample space can be in general discrete or continuous. مثلا rolling a die, what is the sample space? Is it continuous or discrete? discrete لأنه عندك أنت أرقام integers. Picking a positive integer from 1 to 10, discrete ولا?
Discrete.
So rolling a die, it's discrete and finite. Picking a positive integer only without giving you a range, it's discrete and infinite, right?
Yes.
ممكن تعطيني integer مليون. This is an integer. You can have a pointer in a wheel. عندك wheel. الويل هذا فيه pointer. وانت تحرك الويل وتشوف بعدين وين البوينتر وقف عند أي رقم. And you have it basically from 0 all the way كذا إلى 12 ساعة يعني. And you have a very fine, you can basically read any number. ما هي بس integers ولا هي أي شيء. You have very خلينا نقول fine resolution. In this case, the pointer in the wheel can read the sample space here is basically from 0 to 12, right? Which is continuous and infinite, right?
Right.
And countable or uncountable?
Uncountable.
Uncountable. تمام. طيب, let's move. Now let's talk about events in more details. In general, we are interested in characteristics of the outcomes rather than the outcomes themselves. وهذا اللي حنحاول نسويه خلال الكورس هذا. We would like to move away from the physical outcomes إلى ال characteristics حقتهم. يعني what is the probability of the event rather than what is the event itself. طبعا شوي we'll move from there. And we will be able to do that perfectly when we define in chapter 3 random variable. Or chapter 2 random variable. طيب, example here is draw a card from a deck of 52 cards. اللي هي الشدة هذه أو الورقة. عندك 52 كارت. Okay. In this case, the number of events that you can think of is very large. It's 2 to n, 2 to number 52, which is a huge, large number. Okay. Events defined on a countably infinite sample space do not have to be countably infinite. إيش يعني؟ أنا الآن here we have 2 to n. Sorry, الsample space. الsample space, for example, pick an integer. Okay. قلنا الsample space عبارة عن 1 2 all the way. Right? Now events defined here doesn't have to be also infinite. And ممكن I define A as only 1 or 2. So the event here tells you what the event is, basically picking the numbers 1 or 2. Similarly, you can define B that the events from 5, 6, 7, and 10, and so on. So if you have a countably infinite sample space, doesn't have to have all events countably infinite. أنت ممكن you can define if finite events. However, events defined on continuous spaces مثل اللي قلنا عنه from 0 to 12 are usually continuous. طبعا ممكن يكون discrete. لكن usually to make sense continuous. إيش يعني؟ Let's go to this wheel هذا اللي هنا. الآن if you roll the wheel إذا لفيته ممكن يجيك أي رقم, صح ولا لا؟ Is it?
Yes.
Yes.
الآن logically you can define events like what is the event that I read, or the event, for example, that you get in the first quarter. معناها من 0 إلى 3. Right? أو أي event ثاني. If you define an event that you get a number exactly 2.56, it's an event. Right? However, this is usually not common in such experiments. لأن the probability of this to happen is 0. It is 0 because it's a number divided by infinite possible numbers, which gives you 0. So in general, it doesn't make sense, or يعني very unusual to define events that are discrete over continuous spaces. However, it's possible. You can do that. هنتكلم على what is usual, what is not usual only. Now let's talk about the axioms of probability. Now إلى الآن لو تلاحظوا تكلمنا عن ال sample space وتكلمنا عن different events اللي هي subsets of sample space وتكلمنا عن probability that is defined according to the relative frequency. طبعا we'll talk about this in details. نعم.
I have a question.
تفضل.
And here in this example, you have put an event in B equal 2.56. Is this goes with die or with the clock with the 12 seconds?
نتكلم عن clock نحن. 2.56. We are talking about this example. Sorry for confusing you.
All right, because the die we don't have fractions, so it's possible.
Of course.
But for the continuous clock, is this number is it kind of possible to have?
It is possible. Until الآن if you roll the wheel, you have to have a number, right? من 0 إلى 12.
Right.
So the number can be any real number from 0 to 12.
Yeah,
so
but
any real number from 0 to 12 is possible.
Right.
However, what is the probability that you get a specific number?
Near 0.
It is 0, not near 0.
Or 0.
طبعا هنا الآن we'll come to this concept in maybe in the next class. There's a difference between a probability of an event that is 0 and whether the event is impossible. This event is possible, but it has a probability of 0. Probability of 0 معناها ايش؟ معناها the likelihood that it can happen is 0, لكن it could happen.
Right.
واضح؟ ليش ال likelihood that this can happen is 0? Because it's one number divided by infinite numbers. So it's 0. واضح؟ صفر واحد على infinity is by definition 0.
Right.
Okay. So now, in order to define probabilities, we need to have some rules that govern these probabilities. The axioms of probabilities are what this rule is. So let's define probability.
دكتور معليش
تفضل.
لو سمحت.
ايه لا تفضل. ترى يا شباب انا ممكن امشي شويه سريع لكن please stop me. Please. تفضل.
قبل شوي بس اللي هو في المثال للكارتس من
نعم.
وين جاب القانون للايفنت حقه؟ ماني فاهم ليش جاب
قصدك هذا اللي هو 2 to n؟
يس.
احنا قلنا قبل كذا انه if you have any set the number of subsets is 2 to the number of elements in the set. تكلمنا عنها قبل كذا لو تتذكر.
صح.
So here 52 is the set, is the number of elements in the set اللي هي sample space. Number of events لو تتذكر events is a subset. الevent is a subset. خليني اكتبها هنا عشان تتذكروها. Subset of S. An event is a subset. So different events are different subsets of S. Okay? فعشان كذا يطلع لك اللي 2 to n.
تمام جزاك الله خير.
وياك. أي سؤال ثاني يا شباب before I move؟ طيب. Now let's talk about the probability. Probability of an event A. If I have an event A, its probability should have, first of all, a non-negative value. Right? You cannot have a probability, يعني logically الآن نتكلم. You cannot have a probability that has minus 0.5. إيش يعني؟ Doesn't make sense. It has no meaning. So there are rules that define, that govern the probability. أول واحدة, probability of any event is non-negative. This is axiom number 1. Our principle number 1. The probability of any event is always a positive or 0. It cannot be a negative number. This is the first rule. And logically, it makes a lot of sense. The second rule is the probability of S, which is the sample space, is equal to 1. S here is what we call the certain event. إيش يعني certain event? It's the event that must happen if I conduct the experiment. مثلا rolling a die وعندي S is 1, 2, 3, 4, 5 and 6. If I roll a die, can I have anything except one of these numbers?
No.
No way. So S, the elements of S, or S is the certain event. It must happen. One of its element has to happen. So this is called the certain event. And because it has to happen, it must happen, it's a certain event, we set up its probability to the maximum, which is 1. So from these two, we conclude that the probability of any event is between 0 and 1. Right? Always. You cannot have a probability that is negative. You cannot have a probability that is larger than
1.
تمام. Which means that if S, what is the complement of S?
5.
5. So if S has a probability of 1, then what is the probability of 5?
0.
0.
It's 1 minus that, which is 0. Now, the third axiom, or principle, tells you the following. If I have union of events, A1, A2, A3, up to AN, okay, such that these events are all mutually exclusive. ايش معنى mutually exclusive? There are no common elements between
Common
them.
elements.
Exactly. Thank you. There are no common elements between them. So A1, A2, A3, and so on up to AN, every one of them has different elements than the others among the sample space. So they are all mutually exclusive. Then the probability of this union of events equals the summation of the individual probabilities of these events. And this only happens if you have all the A's are mutually exclusive. So their intersection is 5 for different events. So what this says, the probability of an event which is equal, which can be expressed as union of mutually exclusive events, is equal to the sum of the event probability, individual event probability. واضحة؟ طبعا this is very important because now S and phi.
بدك تعيد الرقم الثالث ما فهمت شيء.
طيب sure. الآن let's talk about let me give you an example. S هذا rolling a die اللي مكتوبة هنا. A is even 2, 4, 6. B is odd. تمام. Now, what is the probability of A union B? Also, what is the probability of A?
50
Using a relative frequency concept.
Half.
1 over 3.
تمام. 1 over 2. What is the probability of B?
Also
Half.
half.
طيب, what is the probability of A union B?
1.
1.
ليش؟
Because it is equal to S.
It has all the
تمام.
numbers.
A union B equals S. ممكن تنظر لها من ناحية ثانية. A has no common elements with B. And because of that, I can write that this is equal to the probability of A plus probability of B. لأنه ما في common elements. This is what the third axiom tells you. If you have the union of events, their probability equals the summation of the individual probabilities.
Doctor, here the experiment is rolling a die.
Yes, rolling a die. خليني أكتبها. Thank you. Yes. Example. واضحة يا شباب؟ الطالب اللي سأل عن axiom 3, is it okay with you now?
اوكي دكتور.
تمام. طبعا this simplifies the calculation of probabilities when we come later to more complicated examples, simplify it a lot. تفضل. طيب الآن based on common sense زي ما قلنا engineering and scientific observations, we can define usually probability as relative frequency of occurrence. مثلا coin, tossing a coin, the probability of head is roughly speaking, if you repeat this, think about it, if you repeat this tossing many times, then the probability of head will be the number of heads divided by the number of times you repeat the experiment. So, and this is assuming fairness or what we call statistical regularity. اوكي يعني ما في شيء يخلي الهيد يطلع اكثر من التيل والعكس. The coin is fair, is symmetric, regular. طيب شباب, any questions about the axioms and their definitions and the definition of probability? طيب now let's talk about continuous outcomes. Spinning a pointer on a fair wheel. عندك الويل هذا fair wheel that gives you a number from 0 to 100. يمكن الصورة ما تعكس الشيء هذا بس يعني gives you a number from 0 to 100, any number, any real number. Okay, so S here is any number between 0, any real number between 0 and 100. What is the probability using اللي فهمناه فوق? What is the probability that a pointer falls between x1 and x2? ايش رايكم؟
0.
ليش؟ Between x1 and x2.
عندي
So
ده
between two numbers, right?
ايه.
It depends, I think, about how the board is kind of like drawn or something like that.
ليش؟ فكروا يا شباب.
1%.
We take
Board
range. And each
It is not
range is
said we can
probability.
see it in the board.
لا. Let me tell you that. الآن إذا أنا عندي
between
تفضل.
the number of elements between x1 and x2. Take the number of elements and you use the rule limit where n go to infinity.
Hello. Yes.
هذا أقواس ال n على ال h واللي هو النمبر of element between x1 and x2 over 100.
ممتاز, excellent. So basically here we assume that it's continuous, which means that it's x2 minus x1 divided by 100. صح ولا لا؟ By relative frequency. شباب معايا؟
معك دكتور.
طيب الآن how did we find this? Let's divide the range into n separate segments. خلينا نقسم هذا into n separate segments. Okay? In this case, the probability of every segment is what?
1 over
1 over لا n خلينا نقول
1 over 100.
1 over
خلينا نقول n. It's 1 over n, right? Now, so basically the probability that this pointer falls into two segments is equal to what? 2 over n, right?
Right.
And so on. So الآن assume that we have x2 and x1. هذا x2 هنا x2 وهنا x1. The probability that it falls here is the range x2 minus x1 divided by the total range, which is 100. طيب, I think time is up, so we'll continue from here next time إن شاء الله. أي سؤال يا شباب before we close? Any question شباب؟
دكتور
تفضل.
في اللي هو في البلاك بورد ما يطلع لي اسم الكورس.
إلى الآن لسه البلاك بورد I did not activate it. The blackboard will be used only for quizzes, so don't worry about it. It's too early for that.
Doctor, how about the attendance?
Attendance من ال Teams. التيمز في tool يعطيني attendance. It shows me from what time to what time you are with me.
So doctor, how can we know get the slides or the notes?
طيب تكلمنا عنها قبل كذا and I showed you before. It seems
It's
انك
my
جديد
first,
معنا.
yes,
اي
it's my
ممتاز.
first class.
طيب you can go to the sorry. You can go to Teams